Hello there, this is Observers, greetings from Germany. A few weeks ago I had this nice conversation with Antikytheran Level, a respected member of the 24/7 Flat Earth Discord. It was about some models I've created in Blender to test the different ideas of the shape of the Earth. And as we were around 2 hours and 11 minutes in, he said that there are 18 hours of daylight in the summer at his location. And although it is beyond question that I can't reproduce those 18 hours of a visible and 6 hours of a hidden sun on a flat Earth model, I also wasn't able to show it correctly in the globe model, at least not as exactly as I would have liked. But first let's look at the corresponding part of the discussion again.
There, this is the globe model. I model it the same way, it's just simple modeled. Here's the Earth somewhere around, here should be the sun, where is it, oh Lord. Should be somewhere. There's the sun. Okay, there's the sun. The X is now tilted towards the sun. It's tilted towards the sun.
Yeah.
And here I have positioned a camera at your location where you're living.
Okay.
This is a camera, and I just have to rotate it so I know which is the correct camera that tracks the sun nicely.
Okay.
Which one is it? There are too many movements. This one is the correct one. So, and that's the view out of the camera. You see how perfectly this fits to the observations we do every day outside.
Okay, that's great.
Yeah, it's just simple. It's just a globe. It's just a ball that is spinning.
That's great. That's great that you think that explains that you think that the sun is 93 million miles away and the light is reaching you. That's great.
That's a very simple explanation. It's a very simple explanation.
Listen. First of all, listen. If the globe model's math for the most part didn't work, we've all studied this. You're trying to teach me something that is fucking grade 8 math. Okay, but you can't teach me nothing about the sphere. There's nothing you're going to be able to teach me. Okay, I guarantee you that.
So
whatever you're trying to show me, that's why I was even already before showing you.
I just want to show you how nice.
So now all you did is so now on the flat Earth model. So if we make the sun oscillate in height every day up and down like that drastically, well then we fixed the model. So what are you talking about? You've made this so that you put the Earth on a special tilt as an example. So now show me my part of the world.
Exactly.
Show me my part. Hang on. Show me my part of the world. Okay.
Sorry.
Getting 18 hours of sunlight.
18 hours of sunlight?
Yeah, that's what I get.
Is that at your location? Okay, you see the time here?
Yeah, this is my location, so I would like to see.
Okay, wait. Okay, it sets around 3-5. This time is not exactly.
Fair enough. Yeah, that's okay.
It's just a time.
That's our reference point. That's our reference point. Fair enough. Go ahead. 305 is setting.
305 is setting. It goes up, and it rises at 7 at 10. 10:40.
Okay. So we have roughly 7 hours that the sun went down?
7 hours at night.
7 hours at night? Around, yeah. And when I go here, the sun rises at 10:40, so maybe 10:30. And goes up. And 370 it falls again.
Okay. So there's no 18 hours?
That is fit.
The day is longer than the night.
So there's the day is longer than the night, but there's no 18 hours. What happened to 18 hours of daylight?
18 hours. You sure you have 18 hours?
Yeah, there's places that have 24 hours. So yes, what happened to my 18 hours of daylight at that location?
At your location?
Yes, at my location. What happened to it?
How many hours was this? We have about 6 hours of night or 7 hours of night.
Yes.
If we subtract from 24 hours to 7 hours, we are
it's almost 18 hours.
We are about 70 hours. 70 hours and something. If you see how simple this model is, it makes a really nice prediction.
So go a little higher. So now you're saying go a little higher. So let's move stuff around. So it's okay to move stuff around in your model and make it work. But when I'm telling you how to make the other model work, that wasn't okay. You wanted to say that this model doesn't work.
I have to do nothing here. I just do what everyone say. I created this planet. I created this this sphere
What?
tilted 23 degree, and that's all I've done. There is nothing more to do.
When do I
Okay,
have
so
to
where's
show up my
On
angles?
everything works.
where's the 18 hours? Where's the 18 hours of daylight is what we're asking.
We have 17 hours on this
70
position.
hours and
When you-
Yes, you
something.
have 17. You don't have 18. I'm asking you, where's the 18 hours of daylight that I get?
Well, in this little clip, Antiky said multiple times that there are 18 hours of daylight at his location. In my model, the sun was visible for around 16 to 17 hours, but far away from 18 hours. And this bothered me a little bit, especially because the camera was about 5 kilometers above the surface, which should have made the days even longer. You can hear that I ask him if there are really 18 hours of daylight, and he confirmed it. I nearly could feel his smirk behind his computer, because I was not able to show him the 18 hours of daylight. But as we say in Germany, who laughs last, laughs best. And so we go on and check his information about 18 hours of daylight. There is this site in the internet called timeanddate.com, where you can find all possible information about time zones, day and night cycles, the position of the sun, eclipses and so on. So let us verify the information Antiky has given to me. I go to the site and choose Sun and Moon, Sun Calculator. In the search field I type Toronto and choose Toronto, Ontario, Canada in the pop-up. On the appearing side there is this nice yearly sun graph for Toronto, where we should be able to simply verify the statement of Antiky that there are 18 hours of daylight in Toronto. And it should be somewhere around here. Oops. I think we have a problem. The longest daylight period I can find is 15 hours and 27 minutes. So now I have the question, where are your 18 hours of daylight? All I can see is that you may be able to walk around for 18 hours without the need of artificial light, because the human eye also works very well in the twilight. But twilight is not daylight. So let us look for the definition of twilight. For this purpose, we switch to Wikipedia and we look for the definition of twilight. Twilight on Earth is the illumination of the lower atmosphere when the sun itself is not directly visible because it is below the horizon. When the sun itself is not directly visible because it is below the horizon. Sun itself is not directly visible. Not directly visible. Do you get it? There is some light, but you can't see the sun directly. And in my Blender model, I just had picked the moment when the sun disappears below the horizon. There are possibilities in Blender to simulate light scattering, but this is extremely computational intensive and not part of this discussion. You said that there are 18 hours of daylight. And this means per definition that the sun should be directly visible for 18 hours. And even without any definition, you didn't agree with the model because the sun wasn't visible for 18 hours. And now Time and Date tells us that in fact the sun isn't visible for 18 hours, but for 15 hours and 27 minutes. So let us dive into Blender and try this again. Since the last time, I've made some minor adjustments to the model, so it's on the one hand closer to reality and on the other hand more comfortable to handle. Let us see what I've changed. First, I've stretched the timeline to 1440 frames, so I am now able to make steps of 1 minute. 24 hours times 60 minutes are 1440. Second, I've calibrated the camera controller to 0° latitude at the equator and 0° longitude at Greenwich. Third, I've parented the text object that shows the time information to the correct camera so it won't fly around the screen anymore. Fourth, I've added a controller object to offset the time, so I'm able to adjust the shown timestamp. Fifth, I've made the sun a little bit smaller so that it's closer to what we see in reality. Sixth, I've changed the focal length of the camera to 50 mm, which gives a perspective similar to the human eye. A problem that I couldn't fix completely is the height of the observer camera. In the model and discussion, the camera was about 0.02 blender units above the surface. The camera now is about 0.003 blender units above the surface, but the graphic engine is close beyond its limits. You can see this here, how the objects are jittering around. If I lower the camera any further, the view will arbitrarily jump above and below the surface, and I do not want to trigger any epileptic seizures. What does that mean for our experiment now? Well, the Earth has a radius of around 6,300 kilometers, which is represented in my model by 25 blender units. In that case, one blender unit stands for 252 kilometers. Thus, a camera height of 0.003 means that the camera is about 750 meters above the ground, which causes us to see the sun longer than someone standing directly on the surface. In the model I used during the discussions, we were about 5 kilometers above the ground, so we are now much closer to reality. Added to this error, there are those jittering effects caused by the limitations of the graphic engine. All in all, I'm satisfied with a result which deviates from plus 10 to plus 40 minutes from reality. So let's start. First of all, I moved the camera to Toronto, Canada, which is 43.67 degrees north and 79.38 degrees west. Fair enough. Now I scroll through the timeline until the sun just peeks over the horizon. You see this jittering? Blender hates me for that model. Somewhere around here. So this is the point where the sun is rising and I set our clock to 0. Now I could just play the animation, but because of that many frames we would have to wait around 40 seconds, So I adjust the timeline manually. Okay, we're close. So let me stop the animation and adjust the timeline to the point where the sun just disappears. And what do we see now? "15 hours and 53 minutes, 26 minutes more than time and date has told us, and in the limits between +10 and +40 minutes. Considering the fact that the camera is 750 meters above ground and the graphic engine is beyond its limits, this is a really good result, I think. So I tell you where your 18 hours of daylight are. Just in your imagination. The same imagination that makes you think the Earth is a flat plane, the Sun is dancing around in a spiral, or a vacuum has an index of refraction of 0. But the real question in this video is why you told me there are 18 hours of daylight at your location. I think there are two possibilities. First, you don't know the difference between daylight and twilight. In this case, your statement that I can't teach you anything about the sphere.
But you can't teach me nothing about the sphere. There's nothing you're going to be able to teach me. Okay? I guarantee you that.
It's an amazing example of the Dunning-Kruger effect. You think you're so good, but actually you're so incompetent that you don't even realize your incompetence. Or, second, you lie to me intentionally to lure me into a trap, to satisfy yourself and your religious followers. So I ask you now.
Are you just a lying preacher?